So I shared my screen. Today, what I'm going to show you is a new interface of NETRPOMine. Also, at the end, maybe we can talk about new features that we are going to bring. But let's focus on our call project today. Maybe you are familiar with our solution. So in NETRPOMine, everything starts with creating a new project. I will create a new project and select a folder for my project file to be saved. Maybe I can create a new folder, even webinar call. And inside, I'm going to save my call project. All right, once you created your project file, when you select a folder, actually, all of the layers that we are going to use in NETRPOMine will be located under here. It will become visible for us. And we have a couple of information that we have to work on for the beginning of the project. First of all, as you can see here, the first step, the first layer that we have is borehole data. So we need to bring our borehole data. In the color information, let me work on call project. In the color information, basically what we require, the name or number of the borehole, the depth information, and XYZ coordinates. So first we are reading that information from CSV file. Okay, so it seems like it's matching correctly. If it didn't match, you can just select to make it match. So once we apply, we are going to create the borehole data. We are going to bring the boreholes in here, and you can also see under the borehole data, now we have 66 borehole, and we created their information card, let's say, okay? So borehole information card, and we are going to fill the rest of the information once we proceed, like lithology information, the angle information, and the row sample information later on. So for the second thing, we are going to read the survey or angle information. In here, according to the borehole name, we have dip and azimuth information, which those boreholes are vertical ones, so we don't have any different angle, but still we can read that file. So here that should match with that, and here it should match with azimuth information. Okay, we applied. In the meantime, you can understand that if the software accepts your information, it's going to be checked. Otherwise, you might see some differences. There are two options basically. First, you can get a notification. It will say, okay, that information is not correct, etc. So you're going to get a notepad of saying that there is something wrong. Okay. In that sample file, we are not going to have that issue. For the borehole lithologies, so we are repeating the name or number of the borehole, and according to the depth information, we have different lithologies. For example, it says in between 0 to 9.6 meter, we do have this lithology. And in between 9.6 to 10.3, we do have KM3 lithology. Okay, so it goes at the end of the borehole. This is the final depth of the borehole. And till going there, we do have lots of different lithologies. So now we are going to read or import that information. So it's matching correctly. And we are going to apply. Okay, so now we do have geology information too. And in the raw sample information, once you click it, the software will also tell you that you need to enter the attribute information, which is analyze information. And you can go there, go into the project parameters, and you can type some attributes that we are going to work on. So in the raw sample file that I have, let me check. Okay, I'm going to open it now. So in the raw sample file, quite similar to a lithology, in between some depths, we have either calorie, ash, or moisture information. So those things that I'm going to work on, these attributes need to be defined also in the software. So therefore, let's go to the properties. In the attributes, I will say calorie information, ash, and moisture information that I'm going to bring into the software. As a unit, I will select calorie. For ash and moisture, what I have is percentage information, percentage of ash and percentage of moisture. And I will click OK. So now when you click read raw sample information, the software will allow you to match the information. So from to, and now it's a calorie, should match with the calorie, ash, and moisture. Okay, when we apply, now we are going to bring that information into the software, and also we are bringing that information to each borehole's information card, for example, this one. In the raw sample section, you can see the calorie, ash, moisture part. In the lithology, you can see all of the different lithologies and the angle records. For hole depth, we do have -90, so we are quite aware of that. All right, so these four information is quite enough for starting a project. If we have separate seam information, we can also read the seam information too. It's quite similar to lithology. So whenever we have seam level in between some depths, we can also bring that information into software. So instead of lithology, maybe you can also use the seam, and you can see the seam information. Seam or vein, maybe you're familiar with the vein information. All right, now we do have the borehole. So I would like to manage that data. So a lot of different labels are on at the moment. So I will just leave the borehole number. Then the second thing, boreholes are looking a little bit thin. So I will change the diameter of the boreholes. From options, 3D settings, as a cylinder diameter, I will use 15. So visually, it will help me to see boreholes more thicker. All right. The next thing that I would like to do, let's go to the properties of the project, go to the lithology colors. So now I would like to differentiate the lithologies by assigning them different colors. Um, in the meantime, the lithology that contains coal is this one, okay, KM2. So usually I make the lithology that I'm going to work on is red. So if you do that, basically you're going to see the levels that we have most likely coal, okay? That red levels contains coal information for me, but let's also give another colors to the other lithologies as well. So I will give light colors to the other lithologies, so that it's not going to be a problem for me to separate the red lithology from the others. Maybe like that. All right, the red one we can still see, or usually light colors. So this is helping me to understand what kind of lithologies I have at the moment. And if I want, I can make some adjustments. For example, I can edit the borehole number label here. I can change its color. I can make it bold, right? Or I can bring some new labels. Go into the label, add a label for numeric calorie information, for example. And again, let's make it like that. So now in different levels, I do have different calorie information as a label. So when we bring that calorie information as a label, it's quite hard to understand um, what we have as a calorie and how the distribution looks like. Therefore, we do have row sample displaying feature. In the row sample display, you can select the attributes and you can make that attribute visible in some sort of a legend. And look, even if I close the boreholes, now I can see the levels that I do have the calorie and different calorie information also. So you might say that intervals doesn't tell me anything. I mean, why did we separate that in between 0 to 1369? I mean, uh, basically, software just directly creates a legend in between minimum to maximum information. So our maximum calorie information is probably this one, 5,479, okay? So the software just split that information into four pieces, but I can go to the thematic part. I can edit by using new numeric range. Slot spaces are going to be user defined. In here, I will select the calorie information now. And according to that information, I'm going to define the slot values. So it can start from 0, minimum value, but 500. I would like to select 500 as a slot value. So it's going to separate that information into 11 pieces. All right. Now, So that's not a purple, but the pinky color is the highest calorie that we have. And also the purple one is quite high. And I can make some actually I can get some understanding of the levels. Basically, I do have high calorie content in here in this part, in this region, and I do have low quality material here usually. So it's kind of like in between 1500 to 2500 over here, and in here it's like in between 4000 to 5000. Okay, so this is the information that I have. Let's turn back to the boreholes. What other statistical information I can get from the software is one of them. By right-clicking on the project file, you can get actually length statistic. So if you select calorie information or a length statistics, it is going to give you the maximum calorie content you have as a level is 40 meter. So in 40 meter continuous seam or levels that I have as a maximum. Minimum, I think it's a 5 centimeter. So the minimum level that I have is just 5 centimeter. And average 1.8 meter length I have for the calorie. The other thing that we can get statistics about is attributes. So now I would like to get some statistic about calorie attributes. So now, as you can see here, maximum calorie information or calorie content is 5,479. Did we surprise? No, because we already saw that it was the highest value when we were editing the legends. So the highest one is 5,479 calorie. And average calorie in that sample is 2,600. So this is another information that we can get. Also, we can create a histogram graph. All right, let's say calorie. So this is the distribution of the calorie information. So average 2,600, but most likely, yeah, we do have a lot of material here, but we do also have quite good amount of material in high quality part 2. In a histogram graph, we can also see the distribution. We don't have any bullseye point. Usually it happens in the metallic samples, even though you do have the distribution in some part, small, we do have high content or high calorie, but it's just a straight distribution. Although we do have really long content material also. Okay, other statistics that we can get. I also would like to share some information about the exporting. So let's say we made some changes or updates on the borehole data, okay? Let's say we delete or we create a new borehole file, and then we can export the data again. So the CSV, survey and the row sample. So the CSV will change when we export. if you made changes in the sample file that you've been working on, and if you would like to export, you can just export from here. And also you can get some reports, the borehole lists, lithology records, etc. But I'm going to talk about reports once I start showing the filtering option. So in the borehole operations, we have filter, which is so useful that I can say because, for example, calories, average weight. So let's say I would like to differentiate the boreholes in between 2,000 to 4,000 calorie. Okay, these boreholes is just following that pattern. If I wanted to show one specific lithology, let's say KM2, the lithology that most likely we are going to work on. Now the software basically shows you the levels that you do have KM2, but specifically only it's showing that. And when you have that kind of filter, you can also use borehole operation, analysis, and borehole access. In the other part, we bring the borehole access. So we can see the KM2 lithology and the whole borehole access over here. Also, you can give some transparency to the borehole access. Now, what else we can do? Basically, you can use all the filters together, but let's refresh the information. I mean, reset instead of a refresh. And let's separate that boreholes by drawing an area. Now, I'm going to draw an area and differentiate the boreholes. So in order to make a drawing properly, you need to close the snap features, because if you would like to use the 3D space, you don't need that. Otherwise, software will try to catch something when you have snap on. So, okay, this is the part that I would like to filter. When I click OK, I will filter those boreholes. Originally, I do have 66 different boreholes, but now when I filter in here, you can see that we don't have 66 borehole here. And when you have a filter on, the borehole sign, the icon of the borehole will turn into a blue. So you do have a filter on the boreholes. If you would like to manage those boreholes separately, you can also create a new group. Let's separate that as a zone A and zone B, for example, or zone 1. Okay. So now I do have a different borehole group, which is called zone 1, and I can make a selection of these boreholes manually, or you can use right click on the ungrouped, then right click and send those boreholes to the zone 1. Now when we remove the filter, we can see that in the zone 1 we do have 34 different boreholes, and in the main ungrouped one we have 32. So if I check or uncheck, I can see that. So the different, the thing that I would like to mention here, as long as you do have the groups, as long as you separate the information, you can also get reports, especially for the boreholes are visible on the screen. So for example, Now we are seeing the boreholes that are in zone 1. So if I get a report for list of the boreholes, for example, now I'm going to see 34 boreholes. Okay, it's a 34 different boreholes. Or any other information like report, row sample. All right. So for every level, basically it's showing the attribute values, depth in between, and calorie information, and the distribution. But we do have 34 different boreholes here, not the whole one. When you would like to get a report, just keep that in mind. If you would like to get a separate report, you can use that. If you delete the group that you were created, you don't lose any data. All of the boreholes just moving into ungrouped file once again. So more or less, we're quite okay with analyzing the borehole information. We do have some further operations though, which is resource classification and the Voronoi analysis. So now I also would like to talk about that because those are the features that actually came to us from our clients, basically. These Voronoi feature, for example. If you would like to see some information in specific area, you can use that Voronoi feature. And how? So I will talk about that. So now I would like to see, let's say, area. Drawing an area first. Okay, let's say something like that. Okay. Now I would like to see the potential material. Okay, you can create lots of different areas, and you can query what is the potential resource in here. So go to the borehole, use Voronoi feature, select the area, select the attribute that you would like to use, and click apply. So what it does, basically, according to the area that I defined, it also created the Voronoi areas, so we can think that Voronoi areas as an impact area of the borehole. As a slot interval, I will use 500 again. Minimum attribute will be this. Maximum, let's make this. Okay. After that, you can create a report for every 500 calorie. It starts with 1,500. If you remember, that region was actually high, so we don't have lower content here. Therefore, I think that's why it's starting with 1,500. Okay. So now it shows me the boreholes that inside the range. For example, borehole name this 112, 76, 119, 75. These boreholes are inside this range, okay, 1,500 to 2,000. And the area information of these boreholes and the volume information of these boreholes. So area and volume definitions. What do we mean by area and the volume definitions? Basically, it does quite simple reserve estimation. So as you can see, that small areas here, basically it also shows the areas that we have for this range. Okay, we do have 4 different boreholes in here. That 4 different boreholes weighted average calorie in between 1,500 to 2,000. Or this one, okay, 3 of them, this one. So the area information actually, the total area those boreholes have. This area, this area, this area, and this area. So I will get a help from old friend. Uh, okay. I also would like to explain a little bit what it does. So let's say we do have some calorie information, 2000, and in here we do have 1000. Okay. And according to the levels, we are going to have weighted average calorie information, and which is going to be, if we say that level and this level is equal, then we are going to have 1,500 calorie. It's weighted average. I mean, on the borehole, we do have that amount of calorie. And let's say it's a 1 meter, and it is also 1 meter. With the Voronoi, we are basically finding the impact area of the borehole. Okay, so let's think that this is the impact area of the borehole. So the potential volume as a reserve here is going to be 2 meter, this area, and 1,500 calorie, right? So basically, we can say that if we make a volume here, 1 and 1 in here, so 2 meter length, I'm going to have like this. Its potential volume for this borehole and this impact area. For the others, it also calculates. So if this one also have weighted average 1,500, so it calculates its volume too. But maybe we have 1 meter thickness in here. Maybe. I don't know. Just an assumption. So we might say that we do have 1 meter thickness. So this one, and maybe this one is going to be included in 1,500 to 2,000 slot range, and their total area and their total volume will be this. But like I said, this is a simple calculation. For quick usage, okay, at least you can get an idea what kind of potential reserve that I might have. You can draw any kind of area, and then you can get the potential reserve information according to those calculations. Okay, don't forget that. So the another feature that I would like to talk about is the borehole limit. So when we use the borehole limit, we are actually finding a boundary that will cover all of the boreholes. Okay, for example, this one. If you increase the number, the edges is not going to be sharp. Okay, and maybe it's going to take more material over here. So I think this one is quite okay. All right. So this could be the boundary that I would like to use. You can change the proximity criteria. You can adjust the boundary. You might say that in this region, I'm going to work. It is totally fine and acceptable. So let's say we do have that kind of a boundary, and also um, average distance between boreholes, it's kind of like 200 meter at least. So what I would like to do, I will just go to the expand feature, and I will expand this distance a little bit like that. Okay. So 100 meter, I expand that boundary. And I can also use this one to make some Voronoi calculations. So the minimum is different now. By selecting all of the boreholes now, I'm going to create a report. So, okay, this one is a little bit different than the other one. We do have different volume information here, and we do have different volume information here. But this time we used all of the borehole data. But of course, that will work as long as you have calorie information inside the boreholes. So if you don't have some information in some certain levels, for example, this one was empty because we don't have a calorie information in this one. Therefore, we would like to go further in that whole project, and we would like to create a solid model, more likely, to make some calculations for potential reserve. So while we are moving forward to the solid model, we do have two options. One of them is implicit modeling. The other one is explicit modeling, basically. But instead of drawing cross sections, in that type of data set, you can create surfaces, basically. Let's create a vein or lithology surface. So we are going to use KM2 as a lithology, and top side of the KM2, we are going to create a surface. Okay. And it says select limit if you would like to. So I will select this bound. Sorry. According to this bound, it created my surface, and also it used the top side of the lithology, the KM lithology here. Now we can also do that for the bottom side. Select the limit, which I will use this one. So bound actually worked in this case, right? So this is the levels and the surfaces that I potentially might have a core, basically. And if you would like to get a solid model, explicit solid model by using those surfaces, you will use this feature, solid between surfaces. Just click on it, solid model, select the top surface, select the bottom surface, that's here, and select the limit. Okay. We created a solid model and it says 77 million meter cubic volume we have. Okay. So this is the potential solid that we might have core according to these scene. From style operations, you can give some, let's give it a black color and then give it a transparency. Okay. It is a core at the end. And let's filter the borehole and show me only KM2 lithology. So in NETRPOMine, there are lots of ways that you can um, use to analyze the potential reserve, like Voronoi application. You can make some quick calculations. You can create a volume in between surfaces. You can also use this resource classification feature too. Okay. Well, that works a little bit different. So in the resource classification, basically, we are extending the boundary and we are finding measured, indicated, inferred areas. So let me also explain this one. If we have a couple of boreholes like that, so according to the radiuses that we defined here, measured, indicated, and inferred radiuses, so uh, it basically gives some radius around the borehole. Okay. Let's draw this. And those areas are becoming actually their measured, indicated, and inferred areas and volumes. So we are basically combining. Okay, let's say the first one. So this one is going to be its measured area. And according to the thickness level, we are also going to make some volume calculations. And the second one, this one, by also including this, actually, it's going to become its indicated area. And the other one, maybe let's say a little bit larger than that, it's going to be its inferred area. So let's see how software does that operations as well. So when you use that button over here, it will give you the average distance between boreholes, okay? So average distance between the boreholes is already 266. So I suggest using some radiuses more than that. Otherwise, when you would like to make a volume calculation, it will look like this. Let me show you. Let's turn back to the frame number 1. Like this, basically. And if you give even smaller areas, it is not going to even combine the boreholes, and the potential volume that it's calculating will look like this. Okay, a volume for this borehole, a volume for this borehole. Okay, but we do have a continuous structure, basically. We do have those boreholes, and we do have some continuous structure, most likely. And therefore, I don't recommend giving so small areas. 300, 400, and 500 calculations we are going to make. So let's apply. It is going to create measured, indicated, and inferred areas. All right. So we do have a different areas, and area information is like 4 million meters square, 4.7 million meters square, and 5.6-ish uh, million meters square. And the volume information is just multiplying the effective thickness with the area. Okay, so the depth multiplying with the area will give us the volume. So it says potential volume 62,074,000. Actually, what was the volume of our solid? I think we have something close here. Okay, 77.542. Okay. But we do made a lithological model, and that works actually with attributes. So it works with calorie levels instead of seam levels. It's a little bit different. And also, um, while we can create those reports like that, we can also create a report in Voronoi format too, according to every borehole. Okay, so for this borehole, it has that amount of area that comes from borehole area and the potential volume, effective thickness of that borehole. lithological depth, basically. And then we are repeating. Why? Because the first area has, okay, first area has that uh, amount. The second area is a little larger one, and the third area is different. So repeating the borehole but changing the area information all the time will give us different measurements as well. So this is another method that we can use to make some analysis, of course. What else? Actually, let's also make something like not generating a Voronoi report, but we can also use surface as a limit to that operation. So if you remember, we had those surfaces, so it's the upper surface, it's the lower surface. We can also limit the information. Now, while it's calculating the effective thicknesses, it will use those surfaces as a boundary too. Okay. The other thing that we can do in the software is using implicit modeling. If you want to, you can also create that kind of solids with implicit features as well. But usually it's not working well for that type of minerals, that type of structures. But for showing you the way how we can do it, actually, I can show you. So I will use the lithology information, and as a lithology, I will use KM2. And first, we are going to create some distance function points, which basically creates minus value on the borehole info. And the lithology info. Okay, look. So grid. So these levels, these minus points, are basically where we do have the KM2 lithology. Okay. So now the software will calculate actually which points could be minus points. In this part, actually, you need to make some arrangements in here in beta and C value. So the distribution, the production of the points will change. Okay, let me show you. So as in this example, actually, it can be understood, but let's draw boreholes once again. Okay, while we are arranging that beta and C values, So the software basically create minus points. Let's say this is the borehole. So minus points in here. Okay. Let's say -1, -2, -2, -1. Okay, so the minus points are actually our lithological levels. Let's also make that levels like this. So at the end, software creates RBF points. So first it defines the potential minus points on the boreholes according to the lithology or seam or grade information, even according to calorie. You can also make some models. And then it creates potential minus points inside the grid. Remember, we do have a big grid. This is actually what it's for. So inside the grid, it makes some calculations, and according to the calculations, it assigns some values and fills that part. And then it combines the information. So according to beta value, so if you didn't give any beta value, let's say you used 0, the software basically creates points around this one. Okay, it doesn't go further. It doesn't combine the lithologies. So it says you do have that kind of a solid, that kind of a solid, and that kind of a solid. So therefore, you need to do some adjustments in the beta value. And then we are producing a model. Basically, RBF points are getting calculated, like these points, right? It's a little bit distant from starting point to the end, so it might take a little bit long to calculate all of the RBF points. So okay, the points that we generated even too much. So we need to make some adjustments in beta and C values, most likely. But you know what? We can also filter the potential produced model with these surfaces that I have here. Look, if I create a solid model by using those RBF, and if I filter that solid by using my surfaces, again, it's quite okay for me to create a lithological model. So instead of finding the best suitable RPF points, I'm just helping the software so that I can easily create the potential lithologic model by using the implicit model. So in the geological model, if you produce a model without doing anything, let's check one. Now, I will create one big solid because the solid model that we are going to create is just going to cover all of the RBF points. So again, we do have a lot of different, a lot of points, therefore it might take a little bit. Okay, this is a little bit big sample. Therefore it's taking so long, but what I would like to mention also, it's not for the whole model all the time. You can also separate the boreholes and produce solid models step by step. So let's say we divided before as a zone 1 and zone 2, right? So you can also create a zone 1 model, and then you can create the second model as well. So okay, it doesn't matter how it looks, because I know that it's just trying to cover all of the RBF points. And the next thing that I'm going to do is just use the surface filter into that solid. Look, now I will introduce those surfaces to the software. Okay. As a surface filter, now I'm going to use between surfaces. I will select the 1 and the 2 surfaces, right click. So now I introduce those surfaces to the software. Now produce another implicit. Okay, let's make it black again, give some transparency. Okay, so now this one is also the solid model that I have as a call. Look, you can open the area borders, you can see the triangulations, etc. So this is another solid that you can produce by using implicit modeling features. Next step is going to be actually creating a block model. Either you came here from implicit modeling or explicit modeling, it doesn't matter as long as you define some block settings. Here in this sample, I will use 20 meters and 4 meter. Mm, okay, maybe for this one, okay. Blocking 2024. So in the borehole, we do have analyze values, but in the solid, we just have the solid. We don't have any attribute information. Why we are making a block model because we would like to separate that solid information into smaller pieces like that. And then we are going to assign borehole analyze values into the blocks, into every single block. And there are a couple of ways we can do it. Let's create another block. Copy, basically. I take a copy of this block too. So this one is a copy, right? The same block. So the first thing, the easiest one is just create a composite. With that, basically, we are making a 1 meter distribution of the boreholes. Let me show you. When we make a composite display or calorie, okay, here you can see the distribution. So every 1 meter, we distributed that information into different calorie levels. And then with that distribution, we are going to assign those values into blocks. So wherever the block is, it will going to get information from that level. But there are also a couple different assigning methods as well, like nearest neighbor, inverse distance, and etc. I just wanted to show how it's distributed. A row sample display. Maybe it will be much more meaningful now. So, okay, we do have the whole lithology, but in those levels, we do have a calorie actually. Also in here, look, that yellow ones actually doesn't have any information, but in here, it also shows the calorie. Okay, let's close that one. Let's remove the filter. Turn back to our block model. Now there's a one simple estimation method, which is nearest neighbor, and you can simply select the attribute and according to nearest borehole, it will assign some values. Okay, but you can see some clusters in here. Basically, it's just assign values to the blocks. Uh, Basically, blocks getting value from the nearest boreholes. Therefore, you can see that clusters. Okay. There's another detailed method, which is inverse distance estimation. Now I'm going to do that. So for the calorie info, now I'm going to create an ellipsoid. I will choose the center. Basically, it just recognizes the block model when we choose the center. And I will create ellipsoid layer, and I will make that ellipsoid blue. I will type here some ellipsoid parameters and click apply. Okay, it creates an ellipsoid. If you would like to see the ellipsoid even better, you can give some transparency to the block model. So now you can adjust the angle information of the ellipsoids. So like, oh, it's actually, besides from azimuth, from minus Z, I just adjusted. It seems quite fine. Maybe a little bit like that also, right? So I want that ellipsoid to follow Paul's pattern here. And according to those levels, those ellipsoid shape, it's going to assign some values. And when I say synchronize settings, I will get ellipsoid settings here. Let's make 500. And what it does when we have the ellipsoid and when we use the inverse distance method. So regular method, let's say we do have two blocks here, okay? So the regular nearest neighbor method actually gets the attribute information. Let's say calorie 150, calorie 2000, or 2500, for example. So when we use the nearest neighbor, basically those blocks getting information from the nearest boreholes directly. But when we use the inverse distance, and especially that ellipsoids, uh, we are gathering information inside the ellipsoid like this, okay? So we are going to assign some values into the block that we have in the center of an ellipsoid. So the ellipsoid will gather information from this level. Remember, we also distributed the calorie information, right? So it will gather information from those levels, and it will gather information from these levels. And it will decide which calorie it should be assigned. So more likely it's going to be calorie 2000, right? But if we had calorie 2000 over here, nearest neighbor would have done this calculation. Doesn't care about the angle and the pattern of the ore body. It would just take that information in this level to assign some information to this block. So with ellipsoid, actually, we are just making some adjustments and in getting information inside the ellipsoid. And this ellipsoid is just not only one. Okay, let's say we would like to calculate the calorie value of this one. So ellipsoid actually visits every block and gathers information for each block, one by one. For this one, for example, a different ellipsoid. So ellipsoid visits every block's center and gather information inside the ellipsoid and make an assignment to the block. So this is the logic. Okay, let's do the distribution now. Okay, so now actually we can see how that ellipsoid works, right? Because compared to the other one, it was just getting information from the nearest neighbor borehole. Therefore, we had some clusters. But now in this one, with the inverse distance method, we do actually have a great distribution. And again, we can make some adjustments to the legend. Let's edit according to numeric range of calorie and 500 slots. Okay, 11 pieces again. All right. So basically, this is how it looks like. And if you would like to get a solid model after this, you can also create attribute solid model, which means you can create a solid um, by using some higher calorie levels, let's say 1000. So this is the solid that we have more than 1000 calorie here. Let's make it, let's say 4000. Just wondering. Okay, this is the part that we have more than 4000 calorie, the right side. If you remember our row sample display, and look, the purple ones are in the range of 4000 to 500, I'm sorry, 4000 to 5400. So it is a quite good distribution, right? It's just catching exactly where we have around more than 4000. And even look, didn't bypass those levels too. It's a small slice, but we are getting here 4,000 calorie. Also the block, I mean, block is the same as well. So it's a quite good distribution that we made here. And from the block, now you can get reports. The block reports, density 1.8, let's say. So this is the total volume that we have. It was around 75 million also, yeah. And as a tonnage, because I give 1.8 density, it's just multiplied as a tonnage, we have that amount of material. Yeah. So in every range, how much material we have, we can see it. Okay. So we are almost um, ending the session. So if you have any questions, now I can get your questions too. One last thing, actually, I would like to do. I do have the surface of that cool model because I'm getting questions about that too. So yeah, so this is the surface, and let's get that surface into the project. Get a copy. Okay, so in this surface that I have, actually, when I imported that surface, I had a raster image, but you can also drape some rasters to the surface that you have. So if you have a different color when you drape a raster, you just go to the style of the surface and make it white. So white surface will shoulder up raster as it is, okay? Because in NETRPOMine, when we create a surface, we always assign a different color. So this is the thing. And yeah, now I can get your question.